Okay, so I said I would do this, and this is just the dihybrid cross for a Punnett square. So that just means dihybrid, meaning we're looking at two different traits in these Punnett squares. So what we have to do is we have to account for all of the possibilities that we could find with these Punnett squares. And so if you think about it, this is what an individual looks like. Okay, so it has two alleles per trait, and there's two traits. So we see a total of 4 alleles. And that means that in every single one of these boxes, we need to have 4 alleles. So in order to get 4 alleles, we have to have 2 alleles up here. Okay, and we'll talk about how to determine these, and 2 alleles over here. But just know that we have to have 4 total in the box so that we get the proper amount of alleles in each box. We have to have the proper amount on top. So how you should go about setting this up is you have to come up with all the different possible combinations. So you look at the first D and you match it up with the first W. So you get D, W. You look at the first D, and I'm actually going to try to change colors, make this a little easier. You look at the first D and you match it up with the second W. And so you get D, W. Okay, 2 different combinations. Then you look at the second D and you match it up with the first W. And so you get D, W, a different combination. And then you look at the second D and you match it up with the second W. Again, a different combination. So D, W, and I'm going to go ahead and fill out that other W here. Okay. And then you do the same thing for the other individual. Okay. So you have a homozygous dominant parent with a homozygous recessive parent, and we're going to do the exact same thing for the homozygous recessive. Take the first D with the first W. D, W. You take the first D with the second W, and you get D, W. And you take the second D with the first W, we get D, W. And then we take the second D with the second W. Okay, so again, this is just getting all the different combinations of alleles that we could possibly have. And from here, you just do what you normally do. You fill out the Punnett square the way it should be filled out. So you get D, D, heterozygous, and this would be for plant height. And you get heterozygous for flower color. Okay, now this is actually, if you look at it, this is going to look the whole way exactly the same. Everything is going to be perfectly the same. So you're going to get 100%, your genotype 100% is going to be big D, big W, little w. It's going to be 100% heterozygous for both. And so the phenotypes then will be 100% tall with purple flowers. Now if we go on to the next one is a little bit different. Okay, it takes some different alleles this time, but we are going to do the same principles. Okay, so you're going to cross a heterozygous parent with a heterozygous, with another heterozygous parent. So you're going to take the first B and the first R. B, R. You're going to take the first B with the second R. So you've got B with the R. Then you're going to take the second B with the first R. So you've got B, R. And I know that I've told people, you don't ever put the little letter first. But in this case, we want to keep our genes in order. So the B's code for specific genes. They're coding for the color fur, and then the R codes for a different set of genes that's coding for the smoothness or roughness of the fur. So because they're coding for different genes, we have to keep the genes in order. And so after that, we go with the second and the second. So we get B and then R. And then it's going to look exactly the same for the other parent. BR, try to keep the colors the same, consistent. BR, and then we get BR, and for the last one we get, oops, hold on, a little mistake there. That one is going to be a capital R, and then for the very last one we get all homozygous recessive alleles. And so what we're going to end up with here is, it might be easier to type this. Let's try this. So we're going to get here is BR, BR. We're going to get BR, 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 sorry, BR, BR. We're going to get oh, you know what? I'm sorry. We're going to get BRR. And then we are going to get BRR. And we're going to get BRR. And then we will get BRR. Okay, down here we get BRR. We get BRR. We get BRR. And we get BRR. Okay, and we'll just continue to fill this out. Again, it's the same thing we've done the whole time. Just continue to fill out the Punnett square like we have done the entire time. And again, having the small letters like right around here coming before the big letters, again, those happen only because we have different genes here. Okay, so if we look at this now and we see our possible genotypes, let's see, we have BBRR, we have BBRR, we have BBRR, we have BBRR. Okay, BB, we have that one. We now have BBRR. We have BBR. No, that's a repeat. Okay, BBR. Okay, repeat there. For this one, it's a repeat. This is a new one, BBRR. And this is going to overlap just a little bit, so bear with me. That one, repeat. Okay, that one, we have BBRR. And I think that's repeat. This one is a repeat. This one's a repeat. And then BBRR. Okay, and so now you just go through and you pick your percentages. So this would be 1 out of 16. Okay, so we have 1 out of our 16 boxes has this BBRR. Okay, so 1 out of 16. We have a 6.25% chance. Okay, and go ahead and go through and do the rest of those. But then you look at the possible phenotypes as well. And I'm not going to take the time. We've done this plenty, so you can go ahead and do that. But you know the difference between when you have a homozygous recessive versus homozygous dominant versus heterozygous, what you're going to see. So if you have a big B in there, you know that it is going to be black fur, and if you have a big R in there, you know that it is going to be rough fur instead of smooth. Okay, so hopefully this helped. At least it gave you a little boost into figuring it out. And if you have any more questions on the specifics of this, just let me know. Okay? All right, guys.